Consider a hypothetical scenario where all land-based ice across Greenland and Antarctica melts overnight. This would result in a staggering global sea level rise of 65 to 70 meters. To understand the scale, current scientific data shows sea levels rising at about 4.2 millimeters per year. An instantaneous melt represents an extreme, civilization ending shift, jumping from millimeters to 70,000 millimeters in mere hours. Visualize this transformation. Coastlines across every continent disappear beneath the waves. Major global population centers would be rendered uninhabitable immediately, reshaping our planet's map forever. The cryosphere serves as Earth's planetary mirror. Through the albedo effect, ice sheets and glaciers reflect approximately 80% of incoming solar radiation back into space. When we lose this ice, we lose our protection. Dark ocean water absorbs significantly more heat than reflective white ice. This creates a dangerous positive feedback loop. As ice melts, the planet absorbs more solar energy, heating the atmosphere further and causing even more melting. This is a runaway greenhouse effect, leading to a rapid and uncontrollable spike in global temperatures. We are already witnessing this shift. Satellite data confirms a significant reduction in the extent of older, multi-year ice, signaling that our planetary mirror is becoming thinner and less effective every year. The Atlantic Meridional Overturning Circulation, or AMOC, is a vital system of ocean currents that acts as a heat conveyor belt for the Northern Hemisphere. A massive, sudden injection of fresh water from melting ice sheets would dilute the saltiness of the North Atlantic. This would stop the sinking of cold, dense water, effectively shutting down the cycle. This disruption leads to extreme climate volatility. Without the warm water transported north, the Northern Hemisphere would experience significant cooling and erratic weather shifts. The shutdown of this global conveyor belt marks a tipping point, fundamentally altering how our planet regulates temperature. A paradox emerges as the cryosphere collapses. While sea levels surge, humanity faces a terminal freshwater drought. Most of Earth's water is saline. Only a tiny fraction is freshwater, and most of that is currently locked safely in glaciers. As ice melts, the influx of salt water and the rising sea level contaminate our underground aquifers. This process, known as saltwater intrusion, renders remaining freshwater sources unusable. The result is a total breakdown of global water security. Even with oceans overflowing, access to clean drinking water would vanish for billions, triggering a collapse of basic human survival systems. The Earth's crust is not rigid. Massive ice sheets currently compress the lithosphere beneath them. This deformation creates a state of equilibrium. The sudden removal of millions of gigatons of weight forces the crust to rapidly move upward. This process, known as isostatic rebound, releases immense stored energy. This violent shifting would destabilize tectonic plates, triggering frequent and powerful earthquakes worldwide. Our stable foundation would effectively turn into a hazardous seismic zone. In the wake of total cryosphere loss, global insurance markets would officially categorize the planet as a non-insurable event. Trillions in coastal assets would effectively evaporate. With global markets in decline, governments would lose the capacity to maintain coastal infrastructure. Ports, power grids, and transit networks in low-lying zones would be abandoned to the sea. Survival strategies would shift toward interior plateaus. Emerging resilient centers in high-altitude, inland locations become the new bastions for human civilization and vital data preservation. Earth's climate is not a collection of independent parts. It is a complex, feedback-driven system where every component relies on the others. The cryosphere acts as our planetary mirror. When it breaks, positive feedback loops take over, amplifying warming and accelerating decay. The cryosphere is our primary temperature regulator. Losing this component doesn't just mean melting ice. It means the collapse of the systems that support modern civilization. Understanding this interconnectedness is our greatest tool for preservation.